Okay, dividing complex numbers. All right, the key to dividing complex numbers is we're going to try to get rid of the I from the denominator when we're doing this division. To do so, it's very, very important to understand about the complex conjugate. The complex conjugate really isn't that difficult of a concept, but basically if you have two terms in the denominator, say you have a plus bi, which I know is a little bit confusing with letters, all you do is you keep the same two terms, but you switch the sign in between. So a plus bi, its complex conjugate is a minus bi, or vice versa. If you had a subtraction in between, you simply switch that sign to an addition in between the two terms and multiply both numerator and denominator by that complex conjugate of the denominator. So let's jump into a couple examples where all we're doing is picking out the complex conjugate. So if we have a plus I square root of 5, its complex conjugate is going to be, it's not a plus the square root of 5 times I, it's 2 plus I square root of 5. So its complex conjugate, you simply switch the sign in between, and that would be its conjugate. Now this one's a little bit more difficult with a negative 1/2 I, but you can visualize the real part here to be a 0. So you could say 0 plus 1/2 I would be its complex conjugate, or you could drop the 0 in front and it would just be 1/2 I. Let's get into a couple examples here. We're actually going to go ahead and simplify these down completely doing this division. So on this first one, we have 2 plus 5i divided by 4 minus I. And our goal is to get rid of the i's in the denominator and complete this division. So what we're going to need to do is we're going to multiply both numerator and denominator by the complex conjugate of the denominator. So the denominator 4 minus I, conjugate is going to be 4 plus I. Got to use it both numerator and denominator. So as we multiply this through, this goes back to our multiplication of complex numbers. You're just going to take your time, multiply the numerators together, multiply the denominators together. So I'm going to do this kind of quickly, but make sure you follow along. 2 times 4 makes 8. Outer 2 times I is 2i. Inner 5i times 4 is 20i. And last we have 5i times I is 5i squared. Denominator, 4 times 4 is 16. Outer 4 times I is 4i. Inner negative I times 4 is minus 4i. And there's the key there that those middle terms are going to get to cancel out. And then the last term, we have negative I times positive I is negative I squared. Okay, at this point, a little bit more simplifying down, what we can do is we can say, bring the 8 along. These middle terms are like terms. Oops, I forgot my I. Right, when I did the, let me see, the first outer inner, we had 5i times 4 should make 20i. These middle terms are like terms, so 20 i's plus 2 i's makes 22 i's. And then our last term here, whenever we see that I squared, remember we can replace that with a negative 1. So we have 5 times negative 1 there. For our denominator, the 16 can come along. 4i minus 4i, these make 0i, so they basically cancel each other out. And then minus, we can replace that I squared with a negative 1 as well. So if you're okay with this, hopefully we can follow along. I've got 8 minus 5 is going to make 3 plus the 22 i's. And then 16, the double negative is going to make an addition, plus 17, or plus 1 makes 17. Now to write this in that general form, the a plus bi, what we could do is we could split this apart and make it two separate little fractions. So 22 over 17 with the I next to it. That way you can see the real part and the imaginary part. Let's try one where we're dividing by a monomial. So a single 2i term there. On this, it's a similar idea that you want to multiply numerator and denominator by the complex conjugate of the denominator. So if we have 0 plus 2i, I would probably elect to use negative 2i. 0 minus 2i for its complex conjugate. Now this is maybe not the very, very fastest way to get there. However, this is the most consistent way. Is just remember, use the complex conjugate of the denominator. So 0 plus 2i, 0 minus 2i. A little bit of distributing for our numerator. So we can say negative 2i times negative 5 is going to be positive 10i. Negative 2i times positive 3i is going to be negative 6i squared. And for our denominator, we have 2i times negative 2i is going to be negative 4i squared. For each one of these I squareds, we can replace them with negative 1s. So 10i minus 6 times negative 1 and negative 4 times negative 1. And then a little bit of further simplifying down here, I'm going to go ahead and say that's 10i plus 6 over positive 4. Now, if I wanted to split this apart, and I'm going to rearrange the order just slightly, I'm going to say 6 over 4 plus 10i over 4. So I flip-flopped my two terms in the numerator, which is perfectly okay to do because they're separated by addition. Now with our simplifying down, we can say 3 over 2 plus 5 halves I. So our real part's going to be the 3 halves. The imaginary part's going to be the 5 halves. All right, one more example here. Let's go through 3 plus 4i over 2 minus I. Again, multiplied by that complex conjugate of the denominator. So in this case, it's going to be 2 plus I. Take your time, multiply through, distribute here. So in our numerator, I'm going to get 2 times 3 is going to be 6, outer 3 times I, inner 4i times 2, 8i, and then last we have 4i times I is plus 4i squared. Denominator, very similar. First, outer, inner, last, we have 4, 2 times 2, outer 2i, inner negative 2i, and last we have negative I times positive I is negative I squared. All right, here's the place where we want to be careful, combine some like terms, and replace the I squareds with negative 1s. So the 6 comes along. We can say 3 i's plus 8 i's is going to make 11i plus 4 times negative 1. Replace that I squared with negative 1. For our denominator, the 4 comes along. 2i minus 2i makes 0 i's. Minus, instead of I squared, we're going to replace that with a negative 1. And then our final simplifying down, let's say 6 minus 4 is going to make 2 plus 11 i's. And then for our denominator, 4, the double negative makes plus 1. It's going to make 5. We may break this apart so it looks like that a plus bi form. So take this 5 from the denominator and put a copy with each term in our numerator. We can say 2/5 plus 11/5 I. So our real part's the 2/5, the imaginary part's the 11/5. All right, hope this helps out as you're working on dividing complex numbers. Just be careful, multiply by that complex conjugate or the conjugate of the denominator on each one of these with both numerator and denominator, and take your time simplifying down. You got this.